Okay, so let's look now at the next part of this exercise, where we're going to create a project in ArcGIS Pro, and then we're going to import the data that we've just downloaded from Statistics Sweden. Before we do any of that, let's just quickly recap our file structure. Let's just have a quick look here. So I have now tidied up because I don't want to confuse you at all. So I've removed all the superfluous exercises, the ones that come later in the course. I've actually just moved them into this test area folder there that you don't have. Right now, your SBG051 folder should look basically like this without this test area. So you should have a folder called Docs where there are all the instructions that you've received so far. You should have a folder for exercise 1, which is actually an ArcGIS project, folder for exercise 2, and a folder called Final where you put all of the things that you are going to submit or have submitted for this course, the things that you want graded. And then we have the raw data folder, and this is where we have saved our SCB data. And that is in there. So we have these 3 geo packages, and then this folder containing folders containing shapefiles. And all of this is in a folder with the name SBG051, which is under Documents or Document, however you've called it, and this is stored under H:\homes, whatever it is that yours is called when you're working with a remote desktop. If you're actually working locally on your own computer somehow, then this will be C users, your username for that computer, and then again this path. And remember, this path should not contain spaces, should not contain strange letters, such as Swedish letters, no hyphens. The only thing is upper and lower case A to Z in the standard Western European alphabet, ASCII, 0 to 9 numbers and underscore. And keep the names of each step short. This is a little bit long, to be perfectly honest, but it's okay. The problems will only occur when you're using, well, I say they will only occur, they are more likely to occur when using raster files, and this is a vector file, it's a shape file, it's vector. Some of the raster modules in Arc are very, very old and they haven't bothered to update them, and so occasionally, just occasionally, things will go wrong. And you won't know why it's gone wrong, it just happens. It'll be a mystery to you, you'll be swearing and wondering why the damn thing isn't working, and then you'll realise that there's a space in your path somewhere. So that, as I said, that will happen if you use a space. At some point, it'll come round and bite you in the rear end. So let's start going through these instructions and creating our project. So here we've got these folders, and we are going to start ArcGIS Pro, and we're going to create the project for this week's work. Because we've downloaded to the raw data folder, which is external to the project. And so let's just open ArcGIS Pro. It looks like this, and we want to create a new project. Now up here you should have signed in. If you haven't signed in, do that if you've received your login. If you haven't received your login, have a word with the IT guys. They should be sorting that out. Hopefully you've received it. It's not essential this week. You'll be fine without it. You can go on without being logged in. By next week you really do want to have your login available for you. But feel free to log in this week if you've received it. So let's create a new project. We're going to click on Map here, and it suggests this. It says the project name, well, that's wrong. We want exercise 3, and then we want to save it somewhere. The first part of this address for you guys is fine, but then it all goes wrong. I'm going to change all of this, but you want to be storing this in your documents and then SBG051 folder, like I will. This first part of this address, this path, actually is okay for you if you're working on H:\. But it doesn't matter because you're still going to have to change things. So I'm going to go to C, which you don't. You're staying on H. I'm going to go to my user, and I look for documents there, and then I go to SBG051. And this is where I'm going to save the project. I don't want to go into any of these. I want to stop here at SBG051, click on OK. So I'm going to save the project with this name in this location. So that's the location. If we just double check on the location by going here, we can see SBG051. There is no exercise 3 as yet. SBG051, we will create it now. Create a new folder for this project. Yes, please. Click on OK. And we wait. And we get this come up. This is our project. So if we quickly go back here, because now we have exercise 3, the folder created there. And if we click in there, we can see that we've got our database where the geodata will be stored once we've created it. It looks like a folder here, but it's even got a point there which suggests that it's a file, and it's got this GDB file ending there. Input log is another folder. We've got this index folder. Doesn't matter. More interesting here is this exercise3.aprx, which is the project file for this exercise 3 project. It's the ArcGIS Pro file that says go here and get that data, go there and get that data, read them in, display them on the screen looking like this. A set of instructions. It doesn't contain any geospatial data in itself. It just contains instructions to the program to do things so that you have a project. And then we have this final file here called exercise 3 TBX, which is a toolbox. We won't be using the toolbox this week. Next week we will start using toolboxes. At the moment this is just empty. It's created by default when ArcGIS starts a new project. But we're not going to use it. It's not necessary for us now. What we can look at, if you're at all interested, is that this is 4 kilobytes large, and I said this is empty. And I suspect that this contains probably less than a kilobyte of data, but the minimum size that it can take on the disk is 4 kilobytes. The addresses that the hard disk is divided into cover an area, as it were, 4 kilobytes big. So as soon as you save something, it is at least 4 kilobytes big, even if the data within that address, even if it's sort of snuggled up in one corner, as it were, is only a few bytes big or 1 kilobyte big. It has to take up all of that space. Its home, its address. It can be bigger than that as well, obviously. This one is larger, but that's another point not central to this course right now. It used to be, but not anymore. So let's go back to the project. Here we have the project, and we've got this free data from S3, and we're going to get rid of it because it can be slow to load, especially if you've got a bad network. And if you forget to unmark it, and when you create a map at the end of this exercise, you will end up with a source attribution plastered all over your map for something that's not even visible in your map. So let's just get rid of them. We don't want them. We'll just click on remove there. So now we have this nice empty map. The next thing to do is to read some data into our project. So how do we do that? We go over to Catalog, and we click on Folders here, and we click on Exercise 3 here, but we don't have any. There we can see there's that toolbox, and there's that database, and they've got different symbols now. Click on that, that's empty, there's nothing there. Click on that, there's nothing there either. That's pretty much as expected. But we don't have any data because it's in our raw data folder. And where's our raw data folder? Where is it? Right, okay, so let's click on Folders, Add Folder Connection, and now we've got to find our way to it. So for you guys, click on Home, go to Documents, or Homes rather, Documents, and then SBG051. I'm going to have to go a little bit, I'm going to go around the houses a bit here. Then go to Documents, and then we go down to our SBG051 folder, and there it is, raw data. You can click on that. So now we have access to everything within it. I suggest raw data rather than each individual folder because you can just expand these folders. You could even just link to the SBG051 folder if you want, and then, but yeah, it's not necessary. This is as convenient. So SCB, we want the data, and what we're going to do to begin with is we're going to read in a shapefile. So we're going to click on this, and this is our LAN 3ref99TM, and there it says LAN 3ref99TM region SHP. This is a shapefile, and that we can just drag into there, and it looks like that. So that's the same file as we have stored if we go to raw data and we go to SCB, and we go in there, and we go to that land there, and it's the same thing as this SHP file. Now we've got all of these silly copies here, these lock files. They're used by the program, so to speak, to say, I'm using this file, don't touch it, to other programs. It can be irritating at times, but we've got, and as we can see, it's actually, these are references for each one. You can't quite see it. There are references for each one of these. And so this is, each of these files, these 4 files are included in the shape format, and we only see, when we go to catalogue, we only see this one, because the other 3 are taken for granted as being part of the system, and we don't need to display them here. So now we have this map of Sweden in its different counties. If we right click on that, we can open the attribute table. The attribute table looks like that, and you can see that we've got various if I mark that line there, now that gets marked, that's Stockholm, Uppsala, that's that there. And we could right click on that and go flash. We can right click on it and go zoom to, it takes us there. We can close that now. We've still got this blue line around it. We don't want that blue line around it, so let's just click on that tab up there and click on clear. And we can right click on that and go zoom to layer, wherever that's gone. Zoom to layer, there. So now we can view the whole map again. Do we like the way it looks? We'll say no, it doesn't matter hugely, but let's just click on that and go to Symbology. And click on that. And we could do black outlines if you want to. So there's nothing in the middle now, it's just these outlines. Or we could do something like, say, let's make it all grey, and then kill the outline, click on apply, and then at some point, that grey, my mistake, click on apply, and there we have our boundaries. We could do something, so the outline colour, we could actually, how about we make that white, and then make that 1 point also looks kind of nice, I suppose. We have lots of options. What you choose to do is up to you. So there we have our map of Sweden and its counties. The next step, if we go to the instructions, so we've done all that, we've read in the data, is to read in these, so we've read in this long Sweden 99 TM. The next step is to get this, these Inspire squares with the total population. And here it says 19, 12, 31, but we've now got 20, 12, 20, 31, and at some point in the very near future it will probably be 21, 12, 31. Just the last day of the latest year available. So we go to Catalogue, please, and it's this total population, 1 kilometre squares for this particular date. Click on that. Now we have to click on it and open it because this is a database. And so it can potentially contain many different layers of data. In this case it doesn't, it just contains the one layer, but it could in theory contain many different layers in the SQLite database baked into this GeoPackage format. So that's what we want, and we can drag it into our folder and it's added. In the instructions I believe it says you can quickly look at this. Click on Map and go to Properties, and we can see that the coordinate system is now SWIREF 99 TM. And each of the layers within it has SWIREF 99 TM, the Swedish National Grid. Each of these is also stored in SWIREF 99 TM. If we click on the properties for each of these layers, and we go to Source and Spatial Reference, SWIREF 99 TM there, and we can do the same for this. Properties and Source, Spatial Reference, Projected Coordinate System, SWIREF 99 TM. So they're all, both of these are in the desired coordinate system, and the map itself, the project is now, or specifically this map, has been set to SWIREF 99 TM. It was set to that when we read in the first layer. When we read in the first file, that was the one that set the coordinate system. Let's just quickly save that by using this icon up here. Click on save, because we don't want anything nasty to happen. Now the colour here is pink for this population data. It doesn't have to be pink. The program ArcGIS might have read in some other colour. Let's zoom in a little bit. Let's zoom in on Gävle, and we can see we have these squares here. It's sort of informative in its sense, because it's showing us a square wherever there is population. Everywhere where there isn't a square, there isn't anybody. Nobody lives there. It's just endless forest. Whereas everywhere else there are people living. So let's just quickly look at the attribute table of this, and click on that. And we got all of these polygons coming up. Let's make that a little smaller this time. Let's go down there. And these work in exactly the same way as the counties. I can right click there to mark it. We don't see which one that is. So if I do flash, where is it? No, we don't see which one it is. So let's instead go zoom to, or pan to. Let's do pan to. There we go. And there it is. Did that help us? Do we know where we are? Yeah, we're actually not far away from where we want to be. And the first row in the database is not that far away. So we've identified a row there. So this is a row of data. This may look at first glance to be some sort of raster, because these are squares. And in a sort of sense it sort of is, but it isn't a raster. It's not a raster. This is a vector file where each polygon just happens to be a square, arranged in this nice neat grid. Where there aren't squares, there's no data, therefore it can't be a raster. It's not, no data, as in the concept no data. There is nothing there. We haven't stored anything. Which is the big advantage, one of the big advantages of vector. So there is nothing in between where there are these holes. And each square is a thing, an homogeneous surface, a polygon that is square shaped. Each square in here is connected to a row in the database table. That is our definition of a vector, essentially. So let's just clear the marking there. We can clear it there, or we could have clicked clear up there. And we can now close this table. Well, actually, let's just quickly look at that again. That was a bit silly. I got ahead of myself. Attribute table. We can look at the columns. That I should do. We should go through that and explain. We've got this FID, which is a reference number, an ID, a key for the database. So it says this is a particular object, and it's object number 1. Whatever that means, outside of the database, it may mean there's some other information. But as far as the database is concerned, this object is object number 1. And then we have a couple of columns that are questionable as to their utility here. We've got one called geom, which may also have been called something else previously. I think SCB called them. What did we have when we look? Previously here, yeah, they were called object. Now they're called geom for geometry, and each one is a polygon. And every single object in this is a polygon. So you think to yourself, well, I don't really need to save that for every single object. If they're all the same thing, I can just say this whole layer contains polygons. I don't need to specifically lay it out each time. The reason it happens is because even though layers can only store either points or lines or polygons, in most cases, depends on the file type you're using, even these ones can store another type of data. Let's not worry about that for now. And so you have this explicit statement that this is actually some geometry, and it's a polygon, rather than one of these other things that could be stored. Right. So it's just there, ignore it. The next column, this is also one of these ones that on the face of it looks kind of unnecessary, because each one is 1,000, meaning 1,000 square meters. It's the size of the square, Rutstorlek. Also the name has changed slightly, depending on which version of data you're getting from SCB. As they're all 1,000, we could also get rid of that column. But potentially SCB could deliver data with various different sizes. Therefore, this column is there, and it just so happens that every single one is 1,000 meters. I mean, it says so in the name of the file as well, 1 km. But in theory, there could be varying sizes. So it's there. So those two columns are, as columns of data in the table, are actually kind of access to requirement, really. So then we need to look at the last two columns. So we have the very last column is the population. So that's the number of people living within that object, within this square kilometre. And then we have this column called ruta, which has an ID number, an individual ID number for each square. But this was also an ID number. Well, this ID number over here is the ID number of that object, this thing here on the screen, as it is in this data layer. Whereas this ID number is the ID of the object that SCB maintains, the data entry unit, as it were. The square kilometre that SCB is interested in has that number, whereas this is the ID number for the shape or the vector thing in this database, which is basically derived from this. This is, as it were, perhaps kind of like the parent of it. If you're a programmer, not the same as that, I don't mean it in that sense. This is where it comes from, but this is just a local for the database thing, whereas this is the generalized concept as applied by SCB. So that square with that name will always have that name in another file in another database somewhere else, whereas the ID number could change, could be something else completely. ID number and column, right. These are the two that are of any interest to us, and in fact we don't really care too much right now about these ID numbers. We're more interested in this population. So let's close that and then do some playing around with the colours. So if we right click on the layer, we go to symbology, please, the way it disappears. So here we have the symbology, single symbol, which is why they all look the same. Instead we're going to go to graduated colours. And then we get up this map. And that's kind of okay. I don't like the outline. It makes it look blocky, and I'm not keen on it. So if we click on more here, and then format all symbols, and we'll get rid of this outline. We'll just reduce that to 0. Click on apply, and now we have more of a sort of the spread of the data. Looks more like a sort of a density map should look, with the red values being higher and the yellow values being lower. But there are only 5 classes, so it's kind of, yeah, it's not the most detailed map. So let's click on 15. Now, in previous iterations of this program, that has led to a pain. I mean, it's not perfect. It's ignored these settings I've made previously, but at least it's colouring everything now rather than turning it into a hashing, which is what it did previously. So if you're out running an older version, this might not have worked terribly smoothly for you, and you've got something that looks a real mess, and you have to go in and individually set all of these colours up again. Sorry. But hopefully now things should be a lot better. Seems as if they've managed to get rid of that little bug. But we still have to go in and remove those lines again. Click on OK. And we've got this more nuanced distribution. We can also play around with the method here. Just quickly look at the histogram. So when we look at these 15 breaks, and it says natural breaks, it's tried to identify rather crudely in this the best places to put in a break, to say now we're going over to a new class, now we're going over to a new class, because it looks as if, well, that's a clump of data and that's a clump of data. But what happens if we say do quantile? If we do quantile, it says I want how many squares are there in total? Right, I want to divide the total number by 15, so I have 15 classes. The lowest 50 or the lowest number go in the first class, and then in order by how many people they contain, but still we end up with an equal number of these squares in each class. And so we end up with this rather, as you can see, most of the most of these polygons, these squares, have very, very low numbers. And then there are a few around the urban areas that are red. and then they can end up dominating because we get this huge sort of range of values. Everything's been filled up down here. It's not good. And then if we look at equal interval, and it does that sort of thing, where it just looks at the value and says, right, we're going to have an equal, we just spread the values in the population column, we'll just spread those over there. It's not, and you kind of lose information because actually everywhere, like I said, everywhere has these really low values, except for Stockholm and Uppsala and Gothenburg over there and a couple of other places. So it just kind of looks flat and uninteresting in the rest of the country. So let's instead use that natural breaks, because that seemed to work reasonably well. And if we zoom in here, we've got a fairly good distribution of data. So that's the next part, the first visualization that we can do. We can look at the population distribution over Sweden using these 1 kilometre squares. I think we'll end that video there.